Hello. In this lesson, we're going to initialize image views from our images. The images object is a frame concept for the GPU, but similar to how we work with the physical device through the logical device, we have to create image views to work with the images. We can start by creating a vector member of vk image view object. Then we can add a new function called create image views. I will also define a body for this function in the CPP file. The first thing I will do in this method is to resize the image views to the size of the swap chain images. After that, we will go through each image in the images and initialize a new vk image create info object. We can set the S type of that object. Then we set the image field to the image. The view type will be the image view type 2D. The format will be the surface formats format. We will set each of the RGBA components to Swizzle identity. We can set each component of the image view to equal another component from the image with the Swizzle, but we will not do that in this course. We will also have to set the sub-resource range. We start with the aspect mask. The image will be used for a colored frame, so we set the aspect to color bit. Later in the course, we will use image views for depth textures, where we will set other aspect masks. The base MIP level will be 0. We will not cover MIP maps in the course, so the MIP level count will be 1. We will only have one image layer, so the base array layer is going to be 0, and the layer count is also going to be 1. Finally, we will create the image view from the info that we just initialized. To set it in this for each loop, we will need to have an iterator to the swap chain image views that we want to initialize. And we'll move this iterator after the image view is created by using stdnext. If the result wasn't a success, we will exit the application. Since this is a create function, upon destruction we need to destroy each of those image views. So in the destructor, I will now add a for each loop. I build and run the application to see whether there are any errors. Well, this is fine, so we're done with the swap chain and images. This concludes our presentation section, and we'll start with the graphics pipeline next.